So this is the question. It says 4x all over x minus 5 raised to power 2. So this is a repeated factor, linear factor. You can see that this inside here is a linear equation, and this raised to power 2 is a repeated linear factor, which means that this is x minus 5, x minus 5. So because it's a repeated linear factor, we'll write it twice. But anytime you have situation where you have partial fraction, you can see that this means that the power of this is x raised to power 2, is greater than the numerator. Anytime you have a partial fraction and you're resolving it, the second linear factor must carry raised to power 2. Assuming you have this to be raised to power 3, it will be x minus 5 squared, then x minus 5 raised to power 3. So it must be repeated. So if you do that, you have this. Remember to separate it with a positive sign, then minus, then b carry on. Alright, so if you have this setup, somebody will first ask me, how come, why am I putting the square? Notice that this is the sentence. Say for example, I have x minus 5 equals to, let's say, p. This is the sentence saying x is equals to p plus 5. P plus 5. And if this is x equals to p plus 5 now, see, our goal here is trying to get something that we can use to substitute x. So if this is the sentence, let's now substitute x to be p plus 5. So this is the sentence saying, remember we'll carry this. I'll say let it be equals to p. So this is the sentence p plus 5 all over p. Okay, I could have said p plus 5, then minus 5. But notice that x minus 5 already is equals to something, which is p. Are you seeing it? Which is p. So let's just say all over p squared. That means everything here goes to power 2. So if that be the case, notice that this is the sentence saying 4p plus 20, that is into this 20 all over p squared. And you can agree with me that this is the sentence saying 4p plus 20 all over p squared all over p squared. Now notice that by the time we do this, this will cancel this, so that we are left with 4 over p plus 20 over p squared. So that is the same reason why, notice that this is p, now p squared. So that is the same reason why, the same approach that we are using. That's the same approach we are using. So whichever thing you make equal to, if it's this particular value you make equals to p, or you make x to be equals to any value, that's any variable, you see that you are definitely going to end up having this kind of setup. That is why anytime the denominator is raised to power anything, without stressing yourself to solve all these things to find out, just simply make it in such a way that after the first one you have a second part that is raised to power 2. So if that be the case, I know that assuming I'm using cover up method, I will ignore this, then come to this part and start doing whatever I'm doing. But this time around, I want us to use comparing coefficients. So and by doing comparing coefficients, I'll have that both sides will be divided by the denominator, which is this particular x minus 5 raised to power 2. So let me write it so that this becomes x minus 5 raised to power 2. So 4x all over x minus 5 squared. So this is the method of comparing coefficients we are using. So whenever you're using method of comparing coefficients, always multiply left and right hand side by the denominator on the left hand side, so that this becomes a over x minus 5 plus b all over x minus 5 square, then into x minus 5 square. So what this thing means is that everything here on the left hand side is getting multiplied by this, and everything here this side is getting multiplied by this, so that when you do it, you see that this will cancel this, so that you're left with 4x equals to, when this particular x minus 5 raised to power 2 come and multiply a over x minus 5, you see that one of these is the same thing as saying, if you come and multiply it, remember that what is the left hand side's denominator is what is multiplying everything through. This is the same thing as saying, if this x minus 5 is power square, if you come and multiply this will cancel this, so you are left with x minus 5 that will times a, so a becomes a x minus 5. So this particular one is the same thing with what we have here, so this and this will cancel, so that you are left with plus b into 1, because when this and this cancel, it's just 1, so that means you just have b. So this is the same thing as 4x equals to ax minus 5a plus b. So if you have this, at this junction, you can say by comparing coefficients. So by comparing coefficients, simply means x against constants. Anything that does not have x, consider it to be a constant. So anything that does not have x, consider it to be a constant, so that this becomes the same thing as saying 4x is equals to ax. So on the left hand side we have no constant, so we say 0 is equals to minus 5a plus b. It's just like vector. When you are when you are doing dimensional analysis, if you don't have m on the left hand side, you say that that side m is raised to power 0. That is that m on the left hand side is just 0, rather that m on the left hand side is 0. So if you know that, that means that this side is 0 because there's no constant. So let's compare what we have this side. So this is the same thing as saying comparing coefficients now. I will now have that comparing coefficients now. I will now have that this is the same thing as a is equals to 4. Comparing coefficients simply means what you have that is the same, cancel it out. So a is equals to 4. So and this side, this is the same thing as saying minus 5a crossover. This is the same thing as saying minus b like this. Okay, let's say b now is coming to this side. This will be minus b equals to minus 5a, so that this minus and minus will cancel out. You say divide both sides by minus 1, so that b is equals to 5a. But notice that a is equals to something already, 4. So b is equals to 5 into 4. So b is equals to this is how you solve by comparing coefficients. So I think where students have the most problem is not knowing that once you see this power, it means that the first one you'll be increasing it till you get to that power. Assuming it's 4, you will have x raised to power x minus 5 raised to power just nothing. That is 1, then raised to power 2, raised to power 3, and raised to power 4. So by the time you're through with that, then the second part comes with knowing that whatever denominator you have here, you use it to multiply left hand side and the right hand side, which is what we just did. And after doing it, you now compare your coefficients. Now when you compare coefficients, we have this, so that this is now the same thing as saying 4x all over x minus 5 raised to power 2 is equals to a all over, and a here is 4, so we replace the a with 4. 4 all over x minus 5, then plus 20 all over x minus 5 square. So this is your answer. So please like, share and subscribe. Thank you very much, Academic Daddy. Please share.